think it's 2.3 litre engine. You've got the engine block, that black engine block here. This is the cylinder head. Okay, so you've got the cylinder head here. You've got the fuel pump. So this is the fuel pump. This is one of these old fuel pumps. It's not a modern engine system, which is direct injection. Direct injection systems will compress the fuel to approximately 2,000 to 3,000 atmospheres. That's not true in this case. This will compress the fuel to about 700 atmospheres. Okay. So then you have the outlet from the pump, which then runs the diesel fuel through these lines into diesel injectors. Okay. Now this is an indirect diesel injection, which means that the diesel is injected into a little port at the top of the cylinder, and then trickles down from this port at the top of the cylinder into the piston. Fuel filter. Okay, we've got a dual fueling system. So we've got a big diesel tank on the second floor, and we have a fuel supply infrastructure which runs the diesel in here. We've also got a kerosene infrastructure. Actually, one of the technicians about 8 years ago mixed the kerosene with the diesel. So in fact, this red diesel that we're running here is actually a mixture of kerosene and diesel. It's not a pure red diesel. It's actually a mixture of kerosene and diesel.
Is there any reason for that? Any reason for mixing?
No, you made a mistake. Okay. It was a mistake. So anyway, so we run the fuel. So you can see we've got about half a tank here. This holds about 25 litres. So what I do to fill up the tank is I just open this, and the diesel runs down from one of the upstairs tanks under gravity to fill this tank. And then we close this up, and then you have a fixed amount, maybe, I don't know, 15, 20 litres available to run the engine. So when we run the engine, actually this is all open now, but of course we're not running the engine, so there's no fuel being supplied to the engine because the fuel pump is not running. But when we turn the engine over, when the starter motor turns the engine over, it starts the fuel pump, and the fuel pump starts supplying the diesel to the to the cylinders. There is a little glow plug. This thing here, this switch here, is a glow plug switch, and the diesel passes past the glow plug on all 4 cylinders, and that helps to ignite the diesel. Okay, and it helps to start up the engine. So as I said, we've got a dual fueling system that I put in 2 years ago. So this is intended for final year projects running biodiesels and special research diesels. So we can run this engine, we can fill this up with a special diesel and then run it down this line here. So we've got another fuel measurement system here. You can follow the silver cable. And what we do is we just switch this over. Okay, so all I need to do is switch this over from across this valve, and it switches the fuel line from the conventional diesel to the special diesel that we're busy testing. This engine is going to be upgraded in the next 6 months. So you will be the last class that will be doing experiments on this engine.
Are we taking home?
It's going to be replaced. It's going to be replaced with a modern common rail diesel engine.
Wow.
We will be replacing the diesel engine and the dynamometer. We'll be putting on a 200 kilowatt dynamometer with an electronic control system outside.
Nice.
Fancy. Okay, what else? Okay, so you've got the water brake. So you've got the water brake dynamometer. The water passes through the brake, and when I was closing and opening this, I was closing and opening the brake. All right. So as I closed and opened the brake, I varied the brake torque that was being exerted on the shaft. So this is the torque that was busy braking the engine. Okay. If I overloaded this, I would overbrake the engine, and the engine would start slowing down. Okay? If I turned this anti-clockwise, reduced the torque, then the engine would start speeding up. And you saw when I spun this around, the engine came down.
Yes.
And when I reduced this, the engine was spinning up. Okay, so that's basically controlling the amount of water passing through the water break in this dynamometer. Now this whole thing is sprung. Okay, it's sprung. It's on a loose arm. Now, what that means is that I want to be sure, in order to measure the brake torque correctly, that this is properly balanced. This whole thing is properly balanced. If I over-brake it, okay, then this thing will rotate this way. Okay, if I under-brake it, the engine then dominates the brake and it tips this way. Okay? So by adjusting this, I adjust the water flow through the brake and I adjust the brake torque on the engine. And then as I increase this, so it will swing this way. So I adjust this and then I adjust this to get the right position of this measuring system against that measurement point. When the measurement point is in line with that needle, then the whole system is in balance. And that means that the brake torque of the water through the water brake is equal and opposite to the torque being produced by the engine. So they are perfectly balanced. So that measurement that you were making for the part load on here was the force producing the moment in order to balance the torque being produced by the engine. And then on the high load condition, we added 22 kilograms, right? So we increased the brake torque hugely in order to balance the torque that the engine was producing at the high load. Okay, and then this is just plumbing to facilitate engine cooling. So there's engine cooling, there's engine water cooling, engine oil cooling, and then brake water supply. We had to be sure that the brake water supply was sufficient. That's basically it.
So you know in experimental arrangements, we normally have to put a picture up or something.
No, you don't.
We don't have to.
No, the experimental arrangements. So there's the equipment.
Yeah.
Where you identify all of the components: the engine, the dynamometer, the calibrated drum, the calibrated orifice plate drum, the inclined manometer, the thermometer, the volumetric fuel measurement flow device, stopwatch, dynamometer, meter, tachometer, and then of course one of the things you're going to need, I don't know whether you've taken it, Nadine, did you give them the relative specific gravity?
Yes.
Yeah. Okay, so you need the relative specific gravity, that's a hygrometer. That device is a hygrometer that measures relative specific gravity. And did you take today's atmospheric pressure?
Yes.
Yes.
Yeah.
Did you measure it on the barometer?
Well, I measured before.
Today?
Yeah, but not now.
When before? When did you measure it?
9 morning.
The 9 o'clock section.
No, you should go measure it now. Go measure it now. Let them write it down. So and then you've got the mercury barometer to measure the atmosphere.
Do you want us to put all this into the report?
So that's your equipment.
Equipment, yeah.
You read what's required.
No, but you said no to the pictures, yeah?
So
Do
not
you
to
want
the
us to
picture,
use?
but it's written there with requires, yes, the first page.
It's on at the end, isn't it?
Somewhere
Yeah,
down
there.
there. 3.
Right, short report. That's what's required. You guys don't even read your bloody notes.
So we haven't
And I
yet.
know the
No,
group.
you
Sorry,
know,
I
you
know the
said-
group 2 was making complaints about being given incorrect information.
No, you know,
Because
you-
most of them haven't read their notes.
You said no to the pictures, yeah?
That
So
was
do you
your
want us
group, I
to
think.
draw
Ones
it?
that
Or
making-
Do we have to draw it or
that's what my question was.
Draw what?
this?
No.
Equipment.
Can we draw it for
Well,
format?
if you want
For
to.
format.
So
If you
just
want to draw it, you can, but you don't need
just
to.
state it, that's it. That will be used.
So,
Okay.
so
Plus